So this is the last week for our tutorial sessions. And for the last week, we'll be discussing cloud migration. So let's get into it. So the first question is why migrate to cloud? So let's start with the fundamental questions is that why are organizations moving to cloud? First, there's like significant cost saving. So instead of investing on expensive on-premise servers and data centers, companies can pay like a subscription fee. So it shifts your capital expenditure to operational expenditure, and this improves massively on cash flow. And cloud platforms offer incredible scalability. So if your business experiences suddenly grows, you can scale up resources and you can do that instantly without waiting for like maybe hardware delivery or maybe installation. Third one, cloud computing provides flexibility and global accessibility. So your team can access application and data from anywhere in the world, but with internet connection, of course. So it is crucial for remote work and distributed teams. Fourth one is that cloud providers it enhance your security and disaster recovery. So since cloud providers handle all software updates and maintenance automatically, your IT team can focus on strategic work rather than routine maintenance. So fifth one is cloud platforms have built-in disaster recovery. So if you provide redundancy and protection, it will be very expensive if you build it yourself. That's why you migrate to cloud so that you can have an enhanced disaster recovery for your own infrastructure. Finally, if you move to cloud, your organization can focus on what it does best. So it's maybe like building a product or like serving customers, like innovating. So you can focus on that instead of managing servers. That's why it is important to migrate to cloud if you can. Next one, let's talk about no ops. So it stands for no operation. So this is actually evolution of cloud computing. The cloud provider manage virtually everything. So instead of organizations running and maintaining the servers, whether it be it's like virtual physical servers, no ops take that full automation to the next level. So you got serverless computing and function as a service. Example of this is AWS Lambda or Azure Functions. So developers can just simply write their codes and deploy it, and the cloud provider automatically handles all of the stuff like operational concerns such as scaling, patching, monitoring backups, and disaster recovery. So you never think about your servers and stuff. Very powerful because it frees up your team from operational toil. So developers can just focus entirely on their business logic and features rather than dealing with infrastructure problems. So the cloud provider guarantees you an uptime and it can scale your application automatically based on your demand. And it reduces operational complexity and costs, especially for organization without like a large development operation team. So in a no ops environment, um, there is no friction on controlling the operations. That's why developers can focus on what they do more, which is like delivering value to the business, like writing code to effectively make the better out of it. Now it goes to multi-cloud strategy. So this is where an organization uses multiple cloud providers not without, but just not relying on a single one. So it has very good advantages. First one, it reduces vendor lock-in and dependency. So if you're running everything on AWS, you become dependent on AWS. You are dependent on the pricing, the features, and the policies. But if you got multi-cloud, you have like a negotiating power and can switch provider if you need. Next one, optimize costs. Since different cloud providers have different pricing models, you can use like Azure for like AI services because that's where they're good at, or AWS for your general compute because that's much cheaper. And maybe Google Cloud for data analytics. So this best of breed approach saves money because you can just choose a cloud provider that you think will give you something more benefits rather than just sticking on one. And next one, multi-cloud improves resilience. So if one provider experiences an outage, your business can still continue to operate. So it can have like high availability. So you're not at the mercy of a single provider infrastructure. Because if that one provider shuts down, you have no choice but to shut down as well. So the trade-off is just that multi-cloud requires sophisticated orchestration. What do I mean by that? Meaning is that it adds operational complexity because you have to orchestrate everything from these different cloud providers. So organization just moves to multi-cloud if they masters single cloud operations. And yeah, it's very complex. That's why it's important to have a single cloud first. And if you like manageable to do multi-cloud stuff, you can go to multi-cloud. Internet of Things. So instead of just computers and servers, we now have billions of physical devices embedded with sensors and connectivity. So think about your smart home devices like thermostat, security cameras, fitness trackers, smartwatch, also sensors in factories, smart city infrastructure and stuff. So these devices constantly collects data such as your like temperature readings, motion detection, pollution information, maybe your health metrics if you run like 1,000 steps or if you lose like 1,000 of calories. So these metrics are sent over the internet and it enables the your smartwatch to have a real-time monitoring and automated response. So for example, there's a smart thermostat at your home and it can adjust the temperature automatically or yeah, so the challenge is that there's a lot of data that has been generated. So a single IoT deployment can generate terabytes of data. And that's why IoT is so dependent on cloud platforms because the cloud provides scalability and also storage and maybe processing power as well. So it can handle all this data. So IoT also introduce security challenges because they are not updated easily and have limited security capabilities. Since they handle a lot of data, if you put like a lot of security controls into them, it will be it can lessen the tenacity or like it can lessen the real time monitoring or like flexibility. Yeah. And then we got to edge and fog computing. So they are very closely related and it connects to IoT and cloud computing. So as I have discussed earlier, I talk about latency of like how fast and data comes through. So traditionally, all data from IoT devices travels to a distant cloud data center for processing. So it creates latency or like delay which is very unacceptable sometimes for real-time application because what if you're wearing like an Apple Watch and then you are having a heart attack and then your data got delayed and yeah, you die before you even got a medical attention because there's like a very high latency on your smart watch. So also imagine this one. There's like an autonomous vehicle and they send data to a cloud server hundreds of miles away then they decide to break. So that delay could be fatal. So edge computing solves this by bringing computation to the edge of the network. So it is right where the devices are. So an edge node might be like a local server or gateway or even a device itself. So that's in that way data is processed locally and it will eliminate the latency. So that's why it enables real-time decision making. For computing is similar but it's just varied differently. So it's more like a distributed approach. So it bridge edge devices in the cloud. So with fog computing, you have multiple intermediate nodes between devices in the cloud and that collectively process and filter the data. So it reduces the volume of raw data sent to the cloud and it can save you money or like bandwidth. So if you think of this way, edge computing is computation at the very edge, so right, the devices or the local getaway, while cloud computing is a more distributed form of computing resources between the edge and the cloud. So um, just just a one liner to describe this two. Edge computing reduces your latency to improve your real time processing, while fog computing um, it processes your data closer to the source. That's why it reduces cloud bandwidth usage. So that's all, and thank you for listening to my report.